we're going to finish the last part of lesson 4.2 before we look at lesson 4.10. When you're asked to convert forms, what this means is you're going to be given an equation in either vertex form or intercept form and simply multiply to convert to standard form. With vertex form, remember the template is y equals a times x minus h squared plus k. To convert to standard form, the first thing you'd want to do is try to eliminate the parentheses. Since x minus h is being squared, what that technically means is you have to FOIL it. So write it out 2 times and multiply first, outside, inside, last, and then combine any like terms. If there's an a out in front, the second thing you'll do is distribute the a to all of the terms that were in that FOILed product in step 1. Last but not least, there should be something added or subtracted at the end. Combine like terms with your k value. When you're done, you will have converted from vertex form to standard form, which models y equals ax squared plus bx plus c. When given the x-intercepts or an equation in intercept form, the first thing you're going to want to do is FOIL the parentheses. We don't have to write them out twice because neither of them are being squared, but we will do that same method of first, outside, inside, last, and then combine like terms. When you're in intercept form, the only other step would be to distribute the a value in if one is given. There's nothing at the end to add or try to combine like terms with. And then you'll be in standard form, y equals ax squared plus bx plus c. Let's look at the examples at the right and see if we can model one of these two processes. Our first example is in intercept form. We have y equals x minus 2 times x plus 5. When we're in intercept form, we're supposed to just FOIL the parentheses. So remember, we've done this kind of a little bit in the past. When we FOIL in the parentheses, I'm going to take the first term times the first term. X times x is just x squared. So we have y equals x squared. And then O for FOIL means to multiply the two outside terms, so the first term and the very, very last term. X times positive 5 is positive 5x. The inside terms, so now I'm going to take that minus 2 and multiply it to the x. And then the minus 2 with the positive 5 for the last term, negative 2 times positive 5 would be minus 10. There's the FOIL. All the terms in the first parenthesis multiplied to all the terms in the second parenthesis. When we're asked to simplify here, the terms in the middle will usually have the same exponent for x to the first power. We just combine the coefficients out in front. We still have our x squared first. Positive 5x minus 2x is positive 3x. And then the constant at the end is minus 10. Also notice for step 2, the number out in front is missing, so technically the a value is just 1. We wouldn't have to multiply our quadratic function by 1 because that wouldn't change any of the values. So this is our answer converted to standard form. Let's take a look at example B. Y equals 2 times parenthesis x plus 1 squared minus 6. This is an example of a quadratic function in vertex form. The first thing that we're going to do is take these the parenthesis and write it out twice to FOIL it. So I'm just going to write x plus 1 and x plus 1 side by side. When we do our first, we get x squared. On our outside, x times positive 1. The I for the inside terms, 1 times x is another plain x, and then 1 times 1 just stays 1. Those two terms in the middle would be combining like terms, and that would give us x squared plus 2x plus 1. That's what we get when we FOIL in that step 1 from vertex form to standard form. Notice this time though, we've got a 2 out in front, so we've got that a value. That means we're going to have to put the 2x squared plus, or x squared plus 2x plus 1 in parentheses, and then we need to drop that 2 out in front. So I'm just going to put it out in front right here and distribute it to all my terms on the inside. If we distribute the 2 in, that would give us 2 times x squared plus 2 times 2x is 4x plus again 2 times 1 is 2. That's distributing our a value in. The last thing then that we need to do is take that minus 6, our k, and combine it at the very end. So that'll allow us to combine like terms for our constant. Our equation in standard form will be y equals 2x squared plus 4x, and then 2 minus 6 would give us minus 4. So there's our ax squared plus bx plus c template for standard form. Here's our final example. Example C, we have f of x equals negative on the outside times x minus 5 squared plus 3. In this case, we're once again in vertex form. The first thing then that we need to do is just take the parenthesis and write it out twice and multiply all of our parts together. And that's called our FOIL. If we take x times x times minus 5, another minus 5 times x, and then minus 5 times itself, we would get x squared minus 5x minus another 5x. But then watch this, everybody. Negative 5 times negative 5, we get positive 25 for that last term. Combining those two terms in the middle, negative 5 minus 5, gives us x squared minus 10x plus 25. And then always checking out in front, we do have that a value, it's negative 1. What that means is we're just going to pretty much change all of our signs for this parenthesis. If I distribute the negative in here, in the middle, and at the end, that will give us negative x squared plus 10x minus 25. And then step 3, that final step, we just drop down the k value from the original function, combine it with whatever's at the end for our constant in standard form, and our final answer will be in this case, we have f of x equals instead of y equals. So we want to keep that notation consistent with the original function. Negative x squared plus 10x minus 22. That's converting from either standard form or intercept form to, from vertex form or intercept form back to standard form. We'll add the problems from this lesson on at the very end for our CYU. Switching gears now to lesson 4.10. I know it seems kind of strange to go to the end of the chapter, but this lesson kind of ties in nicely with our graphing as it's really just working backwards. You'll notice we're not going to be graphing, but we're going to be using information that would be on our graph to actually create the quadratic function that forms the shape. And we're only going to work with values in either vertex form or intercept form. So let's take a look at the process. If you're given the vertex of a quadratic function in a problem and you're asked to write the equation, we're going to start by plugging it into vertex form. We're going to plug it in our h value and then plug in our k value. If given intercepts, we're going to do something different. So if given intercepts, we're going to plug it in intercept form. And this is that problem where instead of h and k, we'll plug in our values for the x-intercepts for p and q. From there, you're always going to be given an additional point, somewhere either on a picture or just in the given information. You're going to be given an ordered pair. And what we'll do with that is we'll plug them in our equation for x and y, and then the only variable left that we need to find is our a value. And I'll show you on the right and on the back how this works. Use the given information to write the equation of a quadratic function. In our first example, we're given the vertex and a point. So if we're given the vertex, we're going to identify the x-coordinate as our h value and the y-coordinate as our k value. The first thing you want to do is just write out the template for vertex form. A times x minus h squared plus k. And what we're going to do is take that h and the k and just plug it into the formula for each spot. That would give us y equals a times x minus h is just 1 and plus k is 6. Now notice if h is positive in the vertex, it's going to be negative in our equation when we substitute it in, like so. The second thing then that we're going to do is plug in that point for x and y. So that negative 1, I'm going to plug it in for x in my equation, right there. And then that positive 2, I'm going to substitute for y on the other side. Everything else I'm going to leave as is for now. When I do that, all that's left for our variables is the a value. And we need the a value to let us know if it stretches or compresses and if it possibly reflects over the x-axis. This is where we need to be careful with order of operations. On the inside, the parenthesis would need to be done first. Negative 1 minus 1 is negative 2. Then we would need to square that value. Negative 2 squared is 4. So that becomes a times 4, or 4a plus 6. See what I did there? The 4 should be out in front of the a, and that way the 6 is a separate deal. Now to get a by itself, we would need to move 6 over by subtracting. 2 minus 6 is negative 4, equals positive 4a on the right. Divide both sides by 4, and a equals negative 1. What we're going to do then is take that answer and just go ahead and plug it in up here where we already had h and k simplified. That would make our final answer y equals negative 1 times x minus 1 squared plus 6. That would be our quadratic function written in vertex form. For the example on the right, we're given x-intercepts negative 2 and negative 6. Those would define our p and q values in our equation. As always, start off just by writing the template. Y equals a times x minus p and x minus q. That's when we're given values for intercept form. We plug in the p and q for the parentheses. When I plug in p and q now, we have x minus negative 2 and x minus negative 6. Noting that when you have a double negative, that would actually change to positive in both of the equations. And that gives us y equals a times x plus 2 times x plus 6. The point we're given is negative 3, negative 4. We're going to substitute those values in for x and y. Notice negative 3, we have to plug in x in 2 different locations. And for negative 4, our y value, I'm going to substitute that in over on the left-hand side. Everything else stays the same. Like so. We have a lot of parentheses here, so let's see if we can simplify this and clean it up a little bit. So negative 4 stays on the left. For that first parenthesis, if we take negative 3 plus 2, we get negative 1. And then in that second parenthesis, if we take negative 3 plus 6, we get positive 3. Notice on the right-hand side, this is all one big product. There's no addition or subtraction anymore. That means we're just going to multiply them all together. A times negative 1 times positive 3 will just be negative 3a. To get a all by itself, divide both sides by negative 3. That cancels out. On the left, negative 4 divided by negative 3, that's a double negative, cancels out to be positive 4/3. Once you know your a value, you're set. I'm going to plug it into this form right here where p and q were simplified. So just going to kind of combine those two together to get y equals a, which is 4/3, times the two parentheses, x plus 2 and x plus 6. Definitely take your time when you're trying to simplify. Make sure you plug it into the original formula carefully and write your answer in either vertex form or intercept form. If you're given a graph instead of just the specific information printed out already, decide if you know the vertex or know the x-intercepts. In this first example C, it's pretty clear they give you the vertex right here, so we're going to plug it into vertex form. It does cross the x-axis, but it looks like we'd have to approximate. Intercept form might not be the best use of our templates to use to set up. So if we know the vertex, we know h and k. Let's start with vertex form. Y equals a times x minus h squared plus k. H is positive 1. That means y equals a times x minus 1 squared. And k is negative 2, so we're going to put minus 2. Notice they also mark another point on our graph, 3, 2, up here in quadrant 1. I'm going to plug in 3 for x and 2 for y in the equation. So I'll put 2 on the left for y and 3 on the right for x. Keep everything else the exact same. Like so. If I do my order of operations again like we did on the bottom of the first page, 3 minus 1 is 2. We have lots of 2's on here all of a sudden. And 2 squared is 4. So we have 2 equals 4a minus 2. That 2 that's on the right-hand side, let's move that over simply by addition. And we get 4 equals 4 times a. I think we had that on the last page too, except it was negative. This just means a equals positive 1. If I take that and plug it into this row right here, we would get y equals positive 1, which is actually optional to write, times x minus 1 squared minus 2. That's the quadratic function that would sketch the graph in part C. Our last example D marks the two values on the x-axis pretty clearly as negative 1 and positive 4. Now you could make either of those the p or the q value. I'm just going to write them from left to right. So I'm going to plug in negative 1 for p in intercept form and positive 4 for q. That would give us y equals a times x minus p times x minus q. There's our template. If I plug in negative 1 for p, I'm going to simplify that parenthesis. But when I plug in 4 for q, that parenthesis is already simplified. So in that first parenthesis, I'm just going to make that a plus when I write it out. Y equals a times x plus 1 times x minus 4. Again, look for another point that's on the graph. Looks like they clearly labeled 3, 2 as a point for us to use, which was very helpful. We can substitute that in for x and y into our equation to help determine what our a value is. The y coordinate is 2 on the left, and I'm going to plug in the coordinate x 3 2 times on the right. Again, leaving everything else the exact same. And this allows us to calculate our a value. Looking at those parentheses, 3 plus 1 is 4. 3 minus 4 is negative 1. This is one big product again on that right-hand side. A times 4 times negative 1 will just become negative 4 times a. Be careful here. I've seen students mix this up and move the wrong thing over to solve for a. To get a by itself, make sure to divide both sides by negative 4. That makes our a value a fraction, and it's negative. 2 divided by negative 4 reduces to negative 1/2. Once you know your a value, last but not least, we're just going to plug it in where we simplified our p and q. So I'm going to drop that model down, plug in a on the right-hand side, negative 1/2, and then our two parentheses are x plus 1 and x minus 4. There's your equation in intercept form for the graph of part D. And that's it for lessons 4.2 and 4.10. From your 4.2 worksheet last week, make sure to finish problems 7, 8, and 9. They're just converting from either vertex form or intercept form back to standard form. And then for the worksheet today, using given information to write equations, we're going to do 1 through 12 all.